We'll derive the quadratic formula in this video and then use it to solve quadratic equations. We'll develop the quadratic formula by starting with an example of a perfect square. Here we've got x squared equals 4. So we take the positive or minus square root to get an answer of plus or minus 2. Another perfect square here, this time the square of x minus 3. So again, taking the positive or negative square root, we'll get two solutions. X minus 3 will have to be either negative 5 or positive 5. Adding 3 to each of those equations there will give us those two solutions. In the last video, we looked at the perfect square. A plus b all squared, when expanded, will give us the first term squared, the last term squared, and 2 times the first times the second. What we'll do now is go backwards and look for this form, and then we can factorize it into this perfect square. We'll solve this equation by completing the square. Dividing by 2 firstly will simplify the equation, and then putting the 3 on the other side will give us all the x's on one side so that we can complete the square on that left hand side. So we have an x squared term, we have 2x, and what do we have to add to complete that big square? We'll need 1. And so we add 1 to both sides of that equation, and then we've got the completed square. Our big square here has side length x plus 1, and it follows that pattern of the first term squared, the last term squared, and 2 times the first times the second in the middle. Our 3 plus 1 of course equals 4. We can now take the square root of both sides, and that'll give us a positive 2 or a minus 2. We can then subtract off the 1 to get our two solutions of 1 or minus 3. We'll now do the same thing for the general quadratic equation. So firstly, we'll take a out, and then we will subtract the c over a to get all the x's on one side. And now we need to complete the square. We have an x squared and a b over a times x. We'll split that into two. Half of it goes on this side and half of it goes down here. And then to complete the square, we need to add that b over 2a all squared. So we add that on both sides of the equation. Now we've completed the square, we have our first term squared, our last term squared, and 2 times the first times the second in the middle. We can tidy up the right hand side by squaring our b over 2a will give us b squared over 4a squared, and then getting a common denominator of 4a squared, we need to multiply that c by 4a. So now we can take the square root of both sides, and of course we need to take the positive or minus square root of both sides, and of course the square root of 4a squared is 2a. And now we can subtract the b over 2a to get x by itself. So we'll get that quadratic formula, minus b plus or minus the square root of b squared minus 4ac all over 2a. We can use the quadratic formula to solve this equation. We notice that it's in the form of ax squared plus bx plus c, where the a is 1, the b is 4, and the c is 3. So we can use the quadratic formula and substitute our values in. So our b is 4, our a is 1, and the c is 3. So we need to evaluate that and then simplify it out to get our two solutions there, x equals minus 3 and x equals minus 1. How many solutions will a quadratic equation have? Well, it will depend on the values of a, b, and c. We can get two solutions as shown in that graph there, two x-intercepts that way or this way. We can get one solution only where the parabola touches the x-axis at one point only, or it can completely miss altogether and there'll be no solutions there. The part of the quadratic formula that tells us how many solutions there are is the b squared minus 4ac under the square root there. And the number of solutions will depend on its value. We give it the name the discriminant, and if it happens to be positive, then we can take the plus or minus square root of a number, so we'll get two solutions. If the discriminant is 0, there will only be one solution. And if it's negative, we can't take the square root of it, so we say that there are no real solutions. We've derived the quadratic formula and we've used it to solve quadratic equations. The discriminant tells us how many solutions there are to the quadratic equation.